All right, everybody. Let's kind of get started. I'd like you guys to take out something to write with. This can be in your notes or just scrap paper, whatever. But I'd like us to try and write the sine and cosine equations for this graph. This is kind of what we left off with last time. So let's take a few minutes here at the start, do like a refresher on what we did last time. So I'll kind of walk by while you guys are kind of picking away at this. Just kind of see what you're doing or how you're doing on stuff. So again, we're trying to write the sine and cosine equation for this graph.
Sine and cosine equations.
There'll be different answers, but the process is basically the same until you get down to h, right?
Yeah.
So it's like two different answers, but like they're both, you recycle a lot of the same work for one for the next, right? So get some stuff out. Get started, right?
Does that look like a charger? Switch
So you want to start by finding the
Switch that.
features.
Thank you.
And those will help you get the values for And from there, you'll pick a point to use to find your. Looks like to me. Yes, sir.
Dude, I didn't even keep track of what I did.
This is low, I'm taking my grade here, but whatever parents you have 60.
You have to email me. I have to do that right now.
I don't even know what they're doing. There's only time for that. I should finish my college.
Me and I need to have another match.
I don't do, why is my Emmy?
Where's the new one?
I haven't applied to state or.
Boring. Get started on something, and
Yeah.
a lot of, not starting here. Probably not the only one, but I got you right now. Most of the thing, virtual. So again, I'll kind of, as I'm going, or as I'm giving you guys time to work on stuff, I'll periodically come in and like write in some of the work here, so as you're progressing, kind of check what you're doing, or see what's going good or bad. Kind of get you jump started in the right direction, or it's like, oh yeah, that's the first thing I need to do. And this would very much like mimic a test question. right, or a quiz question? Or you're just given a graph and asked to write? How many points do you suppose this will be worth? This kind of question will be worth? Probably at least 5, right? One for each for A, C, H, and K, and then one other point for kind of getting it all together in the right form, getting things in the right places.
Is this like just finding sine and cosine?
Right, you're just writing the sine and cosine equations for this function. That should kind of start, right? All of that is just for both sine and cosine. Addie?
How do you get C equals 4?
I take my period, the 8 pi, and set it equal to 2 pi absolute value c,
Oh.
and then solve for c, and we always take the positive result for c. Hi, Owen. two possible acceptable answers for the sign based on the midline point you chose to use. Would it matter on the test or quiz which one you gave? Nope. Both would be acceptable. And again, you could simplify those answers more, but I'm not worried about that right now. And here for the cosine answer, again, there's 3 extreme on the graph. So 2 different minimums, 1 different maximum. So any one of those 3 would be an acceptable final answer for the cosine, depending on whether you used, which point you used. Does this all kind of jog your memory about what we did last? Look familiar? Questions on how I did things, or what I did to get our answers, or how I made my choices, or how I got to any of these little parts that we need to go over before we kind of move on to the idea for today? So I'm gonna try to kind of keep touching base with the stuff that we had done recently, because it seems like we're not necessarily getting to our homework right away, so circling back, doing some more reminders should help keep that a little bit fresher, so when you're ready to sit down and work on the homework set, it's not quite as unfamiliar as it would have been if it's been 3 or 4 or 5 days since you looked at the material. So if you haven't done this most recent set, I think that was 7 and 8, and worksheet 5 maybe? I'm not positive, I'd have to go back and look. Keep this handy, so it'll be helpful to you as an exemplar of doing that. Okay. Today though, we're gonna transition and take a little break. We're gonna talk about graphing. This is not the I want though. Is this? There's another one of those. No, I don't want to do this yet. I don't think. All right. Let me look one more time about where everything is here. Okay. All right, so Must have been intending to do this. Okay. Yeah, all right. So today I want to talk about graphing, and then we'll circle back to what I think is the most difficult skill in this chapter would be writing an equation for the sine or cosine function from just given information, not the entire graph, but only like specific stuff. Like we'll give you the minimum amount that you would need to do it. I think that's the most difficult particular skill. That we'll save for the last part of 3.1. We're going to talk about graphing for today. So last time we talked about, two times before I guess, talked about being able to look at the equation and predict what's going on, right? The type of transformation that's occurring. I don't know that I want to do that right now. What I want to do is talk about building a graph from an equation. So the idea here is we're going to take the, oh gosh, do that. The A, C, H, and K from our equation, and then use it to build a map from the values in our parent function to the points in our transform function. And then we can just keep following the pattern to fill up our space that we're provided. So what tends to be the hardest part is going to be pulling those values for A, C, H, and K, and then dealing with the fractions that are going to end up shaking out. Is everybody okay with this plan? All right. So let's do some examples here. So let's say we want to graph this function. Drop in an XY axis for us to use. Oh, that was too far. Hold on. All right. My first step, I want to look at that equation and pull the values for A, C, H, and K. I'm going to call on some of you guys to help me do this. Everybody so far so good? Krista,
Yeah.
can you tell me what the A is for this equation?
Wait.
Two is correct. Yep. Owen, can you tell me the C for this equation?
The C would be
The other two approaches. Like you do the last one here, and I give you another package
not quite sure because
and
I didn't have so it would be more.
Well, remember that this is the general form. Is that, right?
Oh, so you just change it into the general form.
Well, you're comparing it against the general form, yeah. So the C here should be,
Two.
yeah, the coefficient on the X. Everybody okay so far? Gianna, can you tell me the value for h? So the h is this guy. What did you say? 0 is correct, right? Because there's nothing over here. So you can just think about like a minus 0 in there. That's correct. And Kara, can you tell me the k?
-1.
Yep. Everybody so far so good? Okay. What we're going to do now is we're going to write our transformation math. So I'm going to fill in my values for C and H, and then A and K. Is everybody okay with that? So I'm using that map right there. Do you think you're going to use that a lot? Yup. Do you think you should memorize that?
Yep.
If you don't memorize it, what should you do with it? That's a note card thing for sure. So far, so good? Okay. So what I'm going to do is I'm going to do that transformation, and I'm just going to condense it down a little bit on the 5. Yes, Grace.
Are all of these the recordings of today? Are they on MyNoteing?
Yes.
They're on
No, the links to the recordings are on MyNoteing under the links. The notes that I'm writing are on the OneNote. So because this is a sine function, I'm going to use the key points for sine. So the key points here are just the x-intercepts and the extrema. So the mins and max, and then the 3 key points for the first period of sine. So I'm just going to copy these down. These are coming directly from that list of points above. These are points I would provide to you on any test or quiz. You do not need to memorize them. Okay, they don't need to go on your note card. If I'm asking you to graph a sine or cosine function, I'll talk about here in a minute the format which I would give you the problem and the things that I would be looking for and the requirements I'd be having and that jazz.
For number 1, we're only using our study. And there is no
So what I'm going to do now to find my new transform point is I'm going to take each point from my parent function, plug it in to the x and y in my map. So I'd have like 2 times 0 for the x, and then 2 times 0 minus 1 for the y. Well, 2 times 0 is just 0. And then 2 times 0 minus 1 is just going to be -1. So that's like my first transform point that I would use. So what's happening is the point 0, 0 on the parent function has moved to the point 0, -1. Is everybody okay with that idea? We've been transformed. So I'm just going to kind of continue like ripping my way through these. Each time I'm going to take my new x and y and plug it into my function map, simplify it down, and that's my next point that I'll be plotting. I'm going to do all the plugs through before I plot anything, just in case I'll show you how it's easy to check to make sure you've done the arithmetic correctly. Before I start plotting things, I want to have them all to make sure I got them all right before I plot stuff and realize, oh, I made a mistake and I have to go back and erase something extra. So this time I'm going to plug pi over 2 in for x and then 1 in for y. So 2 times pi over 2 simplifies to just pi. And then 2 times 1 minus 1 is just 1, right? 2 times 1 is 2, and then minus 1 from that is,
Oh, I thought it was multiplying 2.
Is everybody, yes? Sure. Everybody still on board with what we're doing? Again, we're just kind of plugging things through. See if you can get the last 2 plugged through on your own. So try plugging the last 2 points through on your own. I'll write up the answers here in a moment. But try plugging these through, make sure you're putting the things in the right spot, handling the fractions. This one's pretty easy as far as the arithmetic goes. We look at the x coordinates now, my new x coordinates. What do you notice about each of them in relation to each other? It's the same distance between each one, right? 0 and pi are pi away. Pi and 2 pi are pi away. 2 pi and 3 pi are pi away. 3 pi and 4 pi, pi away. Does everybody notice that? If that is not the result you get, you've made a mistake. Okay? They should all be the same distance apart. Now, they might not always be pi apart, but they will be the same distance apart. Is everybody good with that? Whether they're 3/4 pi apart, or half a pi apart, or 1/4 pi apart, but they'll all be the same distance apart. Yeah? Good so far? And now look at the y's. The distance between the y's, between -1 and 1, that's 2 units. Between 1 and -1, also 2 units. Between -1 and -3, 2 units. Between -3 and -1, 2 units. That should be the same distance between. And furthermore, that should be the value for A, that distance between them. If that doesn't work out, you've made a mistake. Okay? Probably an arithmetic mistake at that stage. Is everybody okay with that? So, should be very easy to make sure that we have the right values there. As long as you're pulling the AH or ACH and K correctly, the check to make sure you plug the numbers through appropriately is really easy. Everybody on board with me? So far, so good? What I'm going to do now is I'm going to plot these points. Yay. So I have 0, -1, and then I had pi 0, and 2 pi was +1. No. Negative, and then this was pi +1. There we go. And then 2 pi was +2. No, 3. Right? No, it was back down to -1. Pretty googly moogly, Mr. Kulik, you got to remember what you wrote down. And then 3 pi was -3, which is right there. And then we're back at 4 pi 0, or -1. Is everybody okay with what I plotted? So now I'm going to connect these. Notice when I'm connecting them, I'm using a curved line. I'm not using there's no points to this. It's like a smooth curved line. That's one period, right? Everybody's good? The directions on any quiz or test that you take, I'm going to ask you to extend your graph to fill the space provided. So I need this graph to continue on this way and this way still. To do that, though, I'm not going to calculate any more points. I'm just going to kind of follow the pattern, right? So we went over pi, up 2, over pi, down 2, over pi, down 2, over pi, up 2. The next plan would be over pi, up 2, so back up to here. And the same thing now going this way, so I'm going to go over pi, down 2, over pi, up 2, over pi, up 2, over pi, down 2, and then over pi, down 2. Bless you. And then I'll just kind of connect things. And I drew that in 2 different colors so you can see the part that I plotted versus the part that I just extended. Yes, sir?
Are we gonna ever have to graph it like on the calculator?
I'll show you how to do it on the calculator, but for the most part, we're looking at trying to be able to do this by hand. At this stage, anyway. Until we get good at that, graphing on the calculator is the time saver after you understand it. You know what I'm saying? But we will talk about how to do that. Julius. Sure. Everybody, first example was okay. Let's do a couple more. Sound good?
Yep.
Okay. Just by the way, test or quiz time. It's like a 9-point problem, probably. 1 point for finding the correct values for A, C, H, and K. 1 point each for calculating these guys, so that's, and then a point for graphing the first period and a point for extending. So it's a big point problem. There's a lot to do there. There's a lot of places to kind of run aground. Now, what I'm going to tell you is that I will be fairly generous with the partial credit as long as it's clear I can see what you did. So if you make a value and you pick the wrong value of C here, as long as it's like consistently pulled through and like you calculate all the points correctly for the wrong value of C, and you plot all your points correctly for the wrong value of C, and you extend your graph for the wrong value of C, I'll count that as one mistake. Even though everything is wrong, it's wrong because there's just one mistake, right? If you did everything else correctly for the wrong number, you really just made one mistake. Does everybody kind of get that? So it's easy, like if you pull the wrong value of like A, C, or H, or K, everything after that is going to be incorrect. But how many mistakes did you really make? If it's just one mistake, let's give you one deduction on that and be done. Is everybody okay? All right. We'll do another example problem. Zoom in here a little bit. That's now absurdly big. First step on a graphing problem like this, what do we want to do?
Find the age and C.
Yes. Find those coefficients, the A, C, H, and K. Which one is the easiest one to get? Or which two are the easiest two to get?
A and K.
A and K. Great. What's A?
-2.
Great. And what's K?
1.
1. Everybody on board with how to get those two? Okay. The next easiest one to get is the C. What's the rule for finding C? It's the reciprocal of the coefficient on the x. Every single time. Okay? It's a little bit trickier because you have to do something else with the number you read off the graph, but not much, right? What is the reciprocal of 2? 1/2. Everybody good there? Last thing we need to do is get the h, right? What do I might? For this problem, finding the h is going to be much more difficult than the previous one. Why is that?
We have to take 2 out of pi over 2.
Yeah, I have to factor a 2 out of pi over 2. That's an excellent way of phrasing it. So when I factor that 2 out, really what I'm doing is dividing by 2, right? Dividing by 2 is the same as multiplying by the reciprocal. Excellent. How do I multiply two fractions?
Straight across.
Straight across. So that gives me what? Pi over 4. And that's my h. Lily.
Can I go to the bathroom?
Certainly. Everybody on board with me so far? Okay. So we'll write our transformation map. So it's Cx plus h, comma, ay plus k. Again, I'm just using that formula that we'd written down earlier that we said was prime note card candidate.
Can you scroll up a little?
So I can get the.
Yeah,
I
absolutely.
get the.
Absolutely. Yeah, no problem. Again, if you're not done with something, you need a second, you just need me to like pause for 30 seconds or scroll back for 30 seconds. Totally fine to ask. Trying not to buzz through this, but sometimes, you know, like you get excited about it. The math is just so much fun and I want to get to it. You guys get it. You're probably the same way with the homework and be like, oh, it's over already? Let's just start to enjoy this. All right. Oh, and you're good?
Yeah, I'm good.
Okay. So I'm going to now go back to those list of key points. And I need the key points for cosine. So it's a different set of points than sine was. Right? So the spot I'm talking about is right back here. So I'm going to be using these points this time instead of the sine points. Is everybody okay? Now, on a test or quiz, actually I will hold off and I'll show you what the format would be, and then you'll do it as an example or something. That feels good. Oh, great googly moogly. Come on, Mr. Gulick. So again, I've just copied those values from that chart earlier in the notes, right? Do you have to memorize that chart? No. Do you have to put those on your note card, those key points? No. No. If you need them, I will give them to you in the problem, and I'll show you the format in which, like one of these graphing problems would look like on your test, so you know what it looks like. All right, so the plan here is I take my x's and y's and I plug them into the equation that I've just written above, and that'll compute my new points, right? So 1/2 times 0 plus pi over 4. And then -2 times 1 plus 1. So that's going to be pi over 4, -1. Right, 1/2 times 0 is 0. 0 plus pi over 4 is still pi over 4. -2 times 1 is -1. I'm sorry, -2 times 1 is -2. Plus 1 more is -1. Everybody's feel it? It's okay? And I'm just going to kind of keep grinding my way through. So this is going to be pi over 4 plus pi over 4. That's going to give me pi over 2. And then -2 times 0 plus 1 is just 1. Usually the y coordinates nobody screws up. The x's, though, it gets a little fraction heavy here for some of us that are like, oh, I hate fractions so much. And it's like, well, you know, it's just fractions, guys. Oops. So 1/2 times pi is pi over 2. Pi over 2 plus pi over 4 is going to be 1/4 plus 1/2 is 3/4, right? 50 cents and 25 cents is 75 cents, which is 3/4 of a dollar. Again, like when we ask it in the simple way, it's like, oh, of course it is, Mr. Kulik. But like, Why can't all adding fractions problems just feel like counting money? That's kind of what you're doing. Depends on the fractions, right? Nobody's counting money in sevens. And I'm just gonna kind of just keep on grinding my way through this. As I'm doing this though, it's worth pointing out that you should be able to kind of check as you go. So I noticed that my x coordinates, I went up by a quarter, went up by a quarter. So I'm looking good so far. My y's went up by 2, went up by 2, looking good so far. So that's going to be pi, comma 1, right? I have 3/4 plus 1/4 is the whole. Oh my gosh. Mr. Kulik, that last one's a 2 pi. Oh my gosh. I know, can't believe I did that. So I have pi plus a quarter, that's gonna be 5/4, right? And then -2 times 1 plus 1 is -1 again. Feel okay with what we're doing? Yo, my guts. Grab a XY axis real quick. Drop it in. So notice that every tick mark here is a quarter. If I look at the x-axis, right, I have the major grid line, or the labeled grid marks are halves.
I have a counselor meeting in 5 minutes, but I never got a spot.
Okay, go ahead, you pack up and head out. Don't want you to be late, that's fine. Does everybody see that? So every labeled grid line is a half a pi different. So the minor grid lines, the marks in between are gonna be quarter pies. So we're gonna be using those a lot, right? So my first value was pi over 4 -1, correct? So I have that. And the next one was pi over 2, and then +1, is that right?
Yeah.
Yes, okay. And then it was 3 pi over 2 and +3, right?
Here's 3 pi over 4.
3 pi over 4, yes, thank you. Yes, I misspoke. And then it's pi 1. And then 5 pi over 4, -1. Does that look right to you guys? Plot the right stuff? So there's my picture, or for one period. I'm now going to extend this, so I'm just going to keep following the pattern. So like 1 tick mark over, back to the midline, 1 tick mark over, up to the maximum, back to the midline, back to the minimum, back to the midline, up to the maximum, back to the midline, down to the minimum, back to the midline, up to the maximum, down to the midline, down to the minimum, up to the midline, up to the maximum, back to the midline. everybody feel okay with what I did there? Just kind of following the pattern, right? So nothing sneaky. So again, back to the midline, and then to the maximum, and midline, and then minimum, and then midline, and then maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline. We're done. And I'm just kind of connecting my dots now. Woo! That's a workout, right? There's a lot of extra stuff to plot to fill that space. All right. Let's show you what the exam, or how I'll format this kind of a question on the test. What it'll look like, right? So I'll have you guys do this one, and then we'll go through it at the end, and that'll be that. So on your test, it'll have so it'll look like this. And then it'll say like I'll have that. And then I'll have the key points written down. So I have like some blanks and stuff here. Look like that, and they'll have a grid for you to fill in, like an X, Y axis to fill in. So I'm gonna try real hard to like remind you what to do here by like giving you some blanks to fill in to really scaffold this process for you, right? So why don't you guys take this one, try working through it here for a bit. At least fill in this part right now. Once we move along, we'll drop a grid in and for you guys to work through. Also, but you should be able to, if you're doing your OneNote, you should be able to drop this from from the content library. Just copy, like screen grab it, or copy it into your notebook if you're using your computer. If you just want to write on your sheet of paper. But this is like what the format would look like for a graphing question on a test or quiz, plus the place to like plot your points. Yeah.
I just had a question.
Yep. I'll go first.
I don't
So, and this might be obnoxious. With the age, I know you So you did it, you already did the division.
Oh,
Because that was one of 3
yeah.
So you did the division. You did it already.
Oh, so it's just.
So that's easy, right?
Yeah,
Try to pick.
looking at this.
Yeah.
To do.
Right, but that was because it was pi over 2, so we're figuring out what goes there. So this was like a blank, right? To figure out that blank, we did this.
Do that.
So to figure out your blank, we've done 3 pi over 4 divided by 3, which is that. Which is yours. Does that make sense? Yes. So again, while we're sitting here, try filling this stuff through on your own. Depending on what the answer turns out to be, I'm starting to think I may have picked some really terrible numbers as far as graphing purposes go. We may not actually plot this because, well, I could plot it on, we can make our own plot. But building one might stink on this, because I think the fractions are gonna be gross. My fault for using a 3. So I'll just, again, kind of periodically write in some values so that if you've made a mistake on something and missed a negative sign or didn't factor something correctly, like you catch it before you do a million pieces of work and are like, oh my God, I made a mess out of this. I'll try to keep filling these things in periodically so you get less of a mess. Grace?
Can I use the bathroom?
Sure. Yeah, the x's are gonna be kind of nasty here, huh? That's okay. Fractions need love too. Who's afraid of fractions? It's just a number, man. This
Can I
one.
go to bed?
Keep on grinding our way through this. Pi over 6 minus pi over 4 It's gonna be 12s, that's 2 12s minus 3 12s. One third is 4 12s minus 3 12s, so that's 1 12. It's going to be 1/2 minus 1/4, so that's 1/4. We got that. 2/3 is 8 pi over 12 minus 3 pi over 12, so it's going to be 5 pi over 12. Oh no, your candy, or it's not candy, oh, it's a duck. Your duck. Man. Question for you guys. Did the X's match? They're all the same distance apart? It's kind of hard to tell when they don't have a common denominator, right? If I write them all as 12s, and you look at it now, do they all match now?
Yeah.
Now, if I'm going to graph this, what unit am I using on my x-axis? I'm going to use it 12s, pi over 12s, right? All the denominators are in 12s. Wouldn't that make it easiest to graph?
Sure.
Because then I can just count like -3, like 3 units left, 1 unit left, 1 unit right, 3 units right. Now, I wouldn't give you something like this obnoxious on a test or quiz, because 12s are just kind of mean.
Right.
Shaw's like, yeah, it is. Let me show you how I would do this if I were in your shoes. So this is my setup. If I'm given this, notice the x-axis is in quarters, not 12s. Right? So what am I going to do here? Yeah, how many 12s are in a quarter? 3 12s is 1 quarter. So I need to have 3 divisions in each one of these. So I'm going to add in my own extra tick marks here. You guys see that? So we have -3 pi over 12
and then, was it 4 pi over 12? What was it? Now I forget. Yeah, negative 3 pi over 12, and then negative 1. And then I have negative 1 pi over 12, 2. And then I'd have positive, no. And we're down to there. And then we're like 2 tick marks over back up to negative 1. So like that's kind of what I would do in this case. Now, I'm not gonna keep doing that because the extrapolation, like the extension stinks. Like it's a million things to plot. It's beyond what I would expect you to do because it's just like stinking annoying. But that's the way I would make that work, is I would just redo my x-axis with the tick marks where they need to be. You know, like, okay, I need to have 12 of these in place of pi. That means 6.5, that means 3.25. So I'm gonna add 2 extra tick marks in between each quarter, so I have 3 spaces there. And just kind of make it work. That's gonna finish us up for today. That was enough, right? Whew, I'm pooped. So you guys should be able to do I'm gonna ask you to graph 9 through 12. And then we're gonna do worksheet 1. Yeah. And then remember from last week, we had 7 through 8, and then is it worksheet 5?
Yeah.
Okay. So we have 2 things so far in our problem set for Sunday. We have one more sine and cosine topic that we'll talk about in 3.1, but it's probably getting pretty close to homework quiz time. So I might be expecting that by end of this week or start of next. Nothing past 3.1, okay? So pulling an equation from a graph and graphing an equation, I think would be your 2 main topics that you'd be looking to be able to do. Which again, like, and I'll provide you some scaffolding on those, right? I gotta give you the general form and I present the graphing problem in the same fashion that we presented it here. So you don't have to like remember so much. Just have to kind of be able to do it. But I would expect that end of this week or start of next. Probably have a delta math coming up here soon on this, but I have to look at the delta math because I think from last year this was not a great section for delta math because like graphing is hard on delta math. But we'll see, I have to go back and look at what I've done in the past to see if there's a good one there. Everybody feel okay? Was today decent, went slow enough and like did enough example. I hope give you some time to get started on some of these and start